Good evening. Can you hear me?
Yes, sir.
So let's wait for a few more participants, then we will start within 2-3 minutes. Thank you. Good evening. So let's start with this session. Just give me a minute. Okay, so we have two objectives in this session. As you know, we were discussing last time about our classifiers, and we have discussed most of the classifiers. But in this session, we will be discussing support vector machine (SVM), and another is uh, naive-based classifier. So we have two objectives. So first of all, we will discuss its working principle, and then finally, in the end, we will be discussing its implementation. So let's start. And in the completion of this lecture, we will have quiz and attendance, so on. So I want to make it confirm that I know that there are a lot of students from Thapar, and we have uh, your end semester exams are coming. So I think that we will be uh, having next session next week, and after that we will take break for end semester exam, and then we will start it again. So I will discuss that particular point also in this session. So, but let's first start with our discussion. So let's first start with support vector machine, and SVM, as it stand for support vector machine. So in this, it's very important to understand what are support vector and what is the working principle of SVM. So let's first understand that. Here you can see that I have a basic model where there are two attributes x1 and x2. And on these two attributes, I have scattered all the data points which belong to two classes. This is class 1 and this is class 2. And I want to make predictions for any unknown data instance, that this unknown data instance will belong to which of these category. So you can see that in this particular case, our task is to identify a separation line which can separate these two classes. So here you can see that I can identify a separate line like this, or this is another possibility, or these are another possibilities. So you can see that there are multiple possibilities for identification of separation line, which can identify these classes. And you can clearly see that the choice of this particular separation line will affect my output. For example, if here is my new data point, and my separation line is like this. Let's suppose this is class A and this is class B. So if my separation line is like this, then my predicted class will be A. But if separation line is like this, and this is my data point, so in this case, predicted class will be B. So you can see that the predicted class will change with the change of separation line, and both of these separation lines are valid. So it's very important to understand that my prediction will largely depend upon which separation line I will choose. And there are multiple options to choose this separation line. So support vector machine try to use the concept of maximum margin to identify this particular line. So let's understand this particular concept. So first of all, it will consider those instances of two different classes which are very similar to each other. So here we have all the instances, and it will focus on the instances which are very similar or close to each other. can you detect, this is of course the instance of class 1 and these are the instance of class 2. Can you identify those instances which are very close to each other but belong to different classes? So I have to look for those instances which are very similar to each other, but the condition is that they should belong to different classes. So if you look, these are the two instances which are similar, or which are, you can say, close to each other, but these two belongs to different classes. This belong to class A and this belong to class B. So our focus will be on these two data points which are similar but belongs to different classes. You can see that here data point 1 belong to class A and data point 2 belong to class B, and they are most similar with each other. So our focus is only on these two data points, and we try to find, or we try to frame a line which has a maximum margin from these two data points which I have identified. So our whole model is based on these two data points which are similar but belongs to different data points, and we try to frame a line which has the maximum margin from these two data points. So our whole concept is based on these two data points, and these two data points are called as support vectors. So these are support vectors, from where we got the term support vector, because here I have only two attributes x1 and x2, but ultimately these data points are called as vector because there will be multiple dimensions, and whole model is supported or framed on the logic of these two data points. So we called these as support vector because algorithm is only supported by these two vectors, and we try to identify a maximum margin line between these two data points, and this is called as a support vector, and we called that maximum margin line as a hyperplane. So we have a technical term called as hyperplane, which can classify these two data points properly. And on one side of hyperplane is called as positive hyperplane, and another side is called as negative hyperplane. So these are some of the terminologies which are used in case of support vector machine. So again, I'm repeating those who joined a little bit late for them. So we are discussing support vector machine, and in support vector machine, we are taking this data set where I have two classes A and B, which are scattered over two attributes x1 and x2. You can see that all these data points belong to class A and all these belongs to class B. And in this, our our objective will be to identify a separation line which can separate these two classes. And you can see that there are multiple options to select these lines. So what option we should select? Our output will be directly dependent on that selection line, because if you select this line, then this data point will be classified as A. But if you select this selection line, then it will be classified as B. So this selection is very, very important. So what we are doing in this case, we will focus on the data points which are similar, which are close to each other, but the condition is that they should belong to different class. So here, these are the two data points which are similar to each other or close to each other, but they belong to different class. So data point 1 belong to class A and data point 2 belong to class B. So our focus is on these data points. So as you can see, our focus is on these data points. And since here I have only two attributes, so you can say it as a point, but normally we have multiple attributes. So these are actually vectors. So we called them as support vectors because our whole algorithm is based on those vectors. So we call them as support vector, and our idea is to find out a line which has a maximum margin between these two support vectors, or a line which can separate these two data points properly. So we call this data points as support vector, and we call this line as a hyperplane. So data point. And we call these data points as hyperplane. So these are some of the terminologies which are important to understand in the beginning. And now I'm going to explain this concept through a very interesting example of classifying apple and oranges. And I hope that you will like this example, and it will clear most of the intuition behind support vector machine. So here, let's suppose I have to classify apple and oranges, and on one side, let's suppose I have apple, and on another side, I have orange, and I want to classify these fruits both based on their shape, color, and texture. So first of all, as I have mentioned here, we are focusing on those instances which belongs to different classes, but they are similar. यहाँ पे हमारा focus उन apples पे रहेगा. ध्यान से सुनना मेरी बात. यहाँ पे हमारा focus उन apples पे रहेगा which are close to, which has a similar characteristics as compared to orange. So वो apple जो orange जैसा दिखता है, हम उस पे focus करेंगे और उस orange पे focus करेंगे जो apple जैसा दिखता है. So let's suppose these are the core data points जिसमें these are purely red shaped typical apple shape instances. So we will not focusing on these data points. And again, we are not focusing on these data points which are typical orange color oranges we have. So we are not focusing on those data points which are typical in nature, but we will focus on exceptions. So you can see here I have an apple which looks similar to orange because its color is like this or shape is also similar to that. So the objective of my classifier कि अगर मैंने इस एप्पल को प्रॉपरली ऑरेंज से डिस्टिंग्विश कर लिया, ध्यान से सुनना, अगर हमने इस एप्पल को ऑरेंज से प्रॉपरली अलग कर लिया तो ये नेचुरल है कि इस तरह के एप्पल जो क्लियरली एप्पल हैं वो तो ऑटोमेटिकली क्लासिफाई हो ही जाएंगे. तो हमारा फोकस रहेगा इस एप्पल को प्रॉपरली क्लासिफाई करने में जो कि ऑरेंज जैसा नजर आता है. सिमिलरली वी विल फोकस ऑन द ऑरेंज व्हिच appear like apple. So you see, you know that sometime orange appear like this. So our model will focus on these two instances. ये apple है लेकिन orange जैसा दिखता है, orange है लेकिन apple जैसा दिखता है. So we will focus on these two instances. So can you tell me what is the name of these two instances in terms of support vector machine? What we will call these? इनको हम क्या बोलेंगे?
Support vectors.
So these are support vectors. So our model will focus on these two support vectors and they try to follow this. And if our model can separate these data points properly, automatically it can separate all other data points also. So this is the intuition behind working on support vector machine. And you can see that here I'm able to find out a line which can separate it. Okay, can you tell me this support vector machine which I am demonstrating right now, is it linear or non-linear?
Linear.
So this is linear. So this concept is applicable if data is linearly separable. But sometimes we have a data like this, which is non-linear in nature, where you cannot separate data points by using a straight line. For example, here again, I have two different classes. These are the data points which belong to class 1. And these are the data points, outer data points, which belong to class 2. And you cannot classify these data points by using a linear separation point. Whatever line you choose. Anyway, this will not be an accurate classification. So in this case, I need a non-linear classifier which can separate these data points like this. So support vector machine has provision to classify both linear as well as non-linear data. So this is the beauty of SVM, that you can specify a kernel which can also frame a you can say a separation line which can distinguish these data points properly, even for non-linear data. So sometimes the data is not linearly separable. So in case of non-linear separable, we have to use different concepts so that we can classify it properly. And I'm not going in detail about mathematics of this model, but I just want to show you that particular point, that yes, through support vector machine, by using the concept of kernel, we can identify a non-linear separation line also. So SVM has a capability to find out separation line for non-linear as well as linear data. And for this, we have to use, for non-linear data, we have to use a concept called as kernel trick, which can identify this type of non-linear hyperplane. So conclusion here is that support vector machine can work in both the cases, linear as well as in case of non-linear. And let me finally tell you that we have some kind of kernels which are commonly used kernel function in support vector machine. One is Gaussian RBF kernel, another is sigmoid kernel, third one is polynomial kernel. So these are different kernels which are based on mathematical concept, but they have a capability to separate non-linear data point also. So commonly we use RBF kernel, which can work for non-linear data set. And we also have a kernel called as linear, which is used for linear data set. So it means that during building SVM, we can specify okay, what type of kernel we will be using. अगर आपको linear data separate करना है, तो you will use linear kernel. बट अगर आपको नॉन लीनियर डेटा पे काम करना है या आप नॉन लीनियर hyperplane identify करना चाहते हैं, then you can specify any of these kernel, and commonly we use RBF kernel. So this is the point, and through these discussion we will be implementing support vector machine on our data set. So conclusion is that so in support vector machine, our whole concept is lied on the concept of vectors, which are support vectors, which are similar to each other but belongs to different classes. The objective of SVM, intuition of SVM, is that if you can classify these instances properly, naturally you can classify other data point also. So this is for linear data, and it can also work on non-linear data, where it can find out a non-linear hyperplane like this. And in order to work on non-linear hyperplane, we have to mention the concept of kernel, which kernel we want to apply. And there are multiple kernel, and commonly we use RBF kernel, but we also have a linear kernel which we apply if we want a linear classification. So let's go back and implement this particular support vector machine on the same data set which we were discussing. So this is my,
sir.
Yeah, please.
Sir, what is kernel?
Kernel is just a mathematical function which has a power to classify both linear as well as non-linear data set. And we have to specify that kernel during building the model so that it can work, and it can make your classification happen for both linear as well as non-linear data set. So here I am selecting, this is my file and this is my code. So today we are going to implement a support vector machine. So I have to look for that code. Just give me a minute. Yes, so this is the code for support vector machine. So let's implement this. So you know that first of all, we have to import my library. So I am importing all these stuff. Let's open this variable explorer. Then we are creating X and Y, opening our data set. So you can see here, I have age and minutes of music just to revise back. And this is our class attribute, whether the person is going to purchase the product or not. So we know that we have to perform train test split, then feature scaling, and then we have to build the model. So let's first quickly perform train test split. So I have performed train test split. Yeah, all that variable has been created. Then we are performing train test split. So our data is now in feature scaled, and you can see here I have X train, and this is corresponding value is Y train, जिसके ऊपर मुझे मॉडल को ट्रेन करना है. But now this time I'm going to train my support vector machine. So let's quickly see the code for support vector machine. So I hope you can easily understand the code, and that code is very simple. Again, it is a 2-line of code which make it different classifier as compared to others. So here I am importing a class SVC, which is support vector from SVM, which is a part of sklearn library. And here in this constructor, I am passing to attributes, and I hope now you can understand it properly. We are specifying kernel equal to linear. So now you know that. So if I specify kernel equal to linear, it will be creating a linear separation line. And of course, random state is equal to 0 is to select the record randomly, and then in every rerun, it will generate same seed number. And we are fitting it on X train and Y train. So let's execute this line of code. So yeah, we have run it successfully. This is our predictions. Let's see our confusion matrix. So we have to, yeah. So this is my confusion matrix. So let's see the value of CM, and you can see 8 and 2. There are 10 incorrections in this because I have used a linear classifier. So this is the reason that accuracy is not good, but we will be interested in visualizing our code. So let me first execute our method. So this is our function for visualizing. And then we will visualize it on test data. So that visualization, I just want to show you. That is important point. So let's run it on test data. So you can see that this is support vector machine linear. So linear model is generating a linear separation line, and you know that this model is not that accurate. Iski jo separation line hai, kiske jaisi hai? Can anybody tell me? This is similar to
Logistic.
Yeah, very good. So what is your good name?
Nakshis.
Very good, thank you. So yes, this is for similar to logistic, and as the logistic regression has a very less accuracy for this kind of data set. Similarly here again we have a lot of error points. Then let's quickly implement our nonlinear classifier. So here you can clearly see that the only difference is mentioning of kernel. So here, as I have already told you, as I have already told you, we will be commonly using RBF kernel for nonlinear data. So यहाँ पे अगर nonlinear classification चाहिए आपको, so we are just specifying kernel is equal to RBF and remaining code is same. So there is no change, only change in the specification of kernel. So you can try various kernel and then you can evaluate their accuracy, and finally you will select a classifier which will be giving you best accuracy. But I want to remind you that yes, support vector machine is very accurate model, and you can see that in case of nonlinear we having just 7 miscorrected identification, and this is one of the best classifier which we have obtained so far for this data set. Only 7 are misclassified instances. And if you want to see its visualization, let's execute this. And in this case, yeah, so you can see that in this case, the visualization is linear or non-linear?
Non-linear.
Non-linear. और ये किसके similar लग रही है आपको? Is it similar?
KN?
Yeah, it is similar to KNN, but yeah, KNN is just like not that smooth, because KNN is just like a area of a map, map of a country, but here it is very smooth curve and it is a non-linear curve. So this is the point which I want to highlight during this discussion, that yes, it has a capability to apply all these points. And yeah, so here I have mentioned RBF kernel, and you have seen that it has generated a non-linear separation line, but when you specify it linear, it is specifying a
Sir, can you please tell that if we want to use sigmoid or anything else, what we have to write in the like kernel is equal to sigmoid?
Yeah, I think so. So I hope now you know that how to tweak it. So of course you will not remember all these things. So my suggestion is always use Control I, so that you can get the documentation and it will tell you everything that, okay, what are the possibilities that. So here you can see that. So it is already specifying you all the kernels. So linear, I have already used. RBF, I have already used. So there are other options like poly, sigmoid, pre-computed, default is RBF. So everything is there. And through this syntax, you can always try and you can always look into that. So always remember to use Control I, so that you can get know about all these parameters, and you can simply took one more and then you can try it. जल्दी से एक और ट्राई करके देखें क्या? So poly करते हैं.
So if we compare it with random forest, which one we can say that better?
Yeah, so it is important to note that there is nothing like that which is better in that particular case. You have to experiment it on your data set, and normally you have seen that इसमें काफी problem है. You can see 13 and 1. So it actually depend upon your results. So you have to experiment over it, and then you have to choose best classifier. So there is nothing like that which say that okay, this one is best and this is not good. We can of course make some generalized comment, but in any way, whenever you have to apply machine learning in any of the data set, normally data scientists supposed to apply all the classifiers with all different options, with all different parameter settings, and then he has to select best parameter, best classifier, which is giving best result. So that's why we are training you on all the possibilities, and then you have to apply every time all these classifiers, and then you have to analyze it, and then your task will be to pick the best one.
Excuse me, sir, I have one question that mostly sir, the students who are doing MTech or PhD, they come with the data set and they apply various classifiers on it, and they only calculate that which one is better or that. And the committee always says that what is your contribution in that? So can you suggest that what the students can do to improve any classifier, or what contribution they can give to that research?
A good question. So this is very typical case that in most of the cases, we are getting this comment. So first of all, it's very important to understand in that particular case, data set is very important. So most of the time, if data set is already available and you are working on that data set, that will not be considered as a research. So you can create your own data set. That will be a task. And if data set is very noisy, mean that if data set is real and it requires a lot of pre-processing, if you simply build the data set, if you simply build the model on the raw data set, the accuracy is quite low. And then you explain that I applied these data pre-processing techniques and filter and feature extraction techniques that improve the accuracy from raw model to this. So let's suppose if you simply apply your model on the raw data, the accuracy is, let's suppose, 60%. Then you apply some kind of pre-processing, use some kind of feature extraction technique, then you perform some performance tuning based on the parameters. Then you show that I have improved the accuracy from 60 to 80 by using these kind of stuff. So then it can be considered as a good research as compared to just applying raw on available data. So for example, if someone apply machine learning on the data set which I am using, that will not be considered as a research. This is just for practice. This is just for lab session to teach the course to the students. But in order to do the research, you have to take some real data set which have a lot of complexity. You should solve it. There should be some noise. There should be some missing values. And then you have to deal with all those stuff and then come up with your solution. So of course, there are other mathematical approaches also where one can dig deep into and provide some solution to any machine learning problem in the algorithm, but there is no further improvement possible in those algorithms. So normally these are the challenges and these are the stuff where people are working. So let's start with our final classifier, and as the name indicates, this is a naive Bayes classifier. And as it explained, it is based on the concept of Bayes theorem. So this is interesting that Bayes theorem was given in 1800, and still people are using this particular Bayes theorem, and now people are using it for machine learning. And here we have a classifier which are completely based on this theorem, and we called it as a naive Bayes classifier. And this is the Bayes theorem. It is based on the concept of conditional probability. So let me explain it a little bit. So here you know that this is the probability of event B, this is a probability of event A, and this is a conditional probability. Conditional probability mean that probability of occurrence of event A when you know that B has already been occurred. So B already occur हो चुका है और उस केस में A के होने की क्या probability है. then that case is called as conditional probability. So B has already occurred. What is that? What is the probability that next event will be A? So in order to check this, we can apply this Bayes theorem, which simply state that it is equal to probability of A to B into P of A divided by P of B. Here in this case, A has already been occurred. What is the probability that next event will be P? And again, in order to explain this point, I will be taking this particular data set. Here you can see that I have two attribute X1 and X2. On one side, I have salary. On another side, I have age. And on that basis, I want to predict that whether the person will come to office by walking or by driving the car. So मैं predict करना चाहता हूँ कि जो नया data point unknown instance आएगा, वो office walk करके आएगा या drive करके आएगा. And in this case, I am going to apply naive-based classifier. So I have two classes. On one side, I have walk. On another side, I have a drive. And let's suppose this is a new data point, and I want to predict that whether this new data point is going to will be going to commute to the office through walking or through drive. So this is my problem statement, and I have data on the basis of age and salary. और मैं ये predict करना चाहता हूँ कि ये जो बंदा है जिसको मैं X बोल रहा हूँ, ये office walk करके आएगा या ये office drive करके आएगा. Now we have to frame our problem statement in term of Bayes theorem, which says like this कि आप इस तरह से कुछ कर सकते हैं, and it is all about probability. And in this case, this is my X. So what I will be doing here, I know that this X is the person जिसके लिए मैं prediction करना चाहता हूँ, and this event has already been occurred. So I will be checking probability for X is already there, and I want to check that what is the probability that this person will be walking to the office. And similarly, I will be also checking my probability for X for drive. So मैं दोनों probability check करूंगा कि X already occur कर चुका है अगर, तो इसके walk करने की क्या probability है कि वो walk करके office आएगा, और क्या probability है कि ये drive करके आएगा. So I will compare both the probability, and where the probability will be more, I will be predicting that particular class as a final class. So this is the intuition. So here I will be calculating the probability that X has already been occurred, and what is the probability that he came to office through walk. And the same way I will be comparing, I will be calculating the probability that X came to office as a drive, and then I will compare both the probability, and where the probability will be high, that will be my final predicted class. So this way I can apply Bayes theorem to calculate that conditional probability, and this is the idea to this is the intuition for Bayes applying Bayes theorem in this classification task. So let's understand it more deeply. So as I have already told you, X is an instance which is already there, and I want to predict that what is the probability that this particular person is coming by walking. So I have to calculate this value, and in order to calculate this value, I can apply, of course, Bayes theorem, which simply state like this. I have to calculate all these values, X to walk, P of walk divided by P of X. So this is clear application of Bayes theorem, which simply states that this probability of B to A into P of A divided by P of B. So you can see here. So मैंने यहाँ पे वही किया है, आपको ये कैलकुलेट करना था, तो आप यहाँ उल्टा कर रहे हैं, तो मैंने चेंज कर दिया, walk to X कर दिया, then it is multiplied by P of A. So P of walk divided by P of X. So ये Bayes theorem हमने अप्लाई की, और इस थ्योरम को मैं इस केस में अप्लाई करता हूं, तो आई विल बी गेटिंग दीज वैल्यूज. सो नाउ आई हैव टू कैलकुलेट माय these equations. So for this I will be taking some numbers, and then I am calculating all these values. So this is interesting. So try to follow all my points, and if you have any doubt, you can ask me any question. So we have to calculate these points. So I will I have to calculate probability of walk, which we called it as prior probability. We have to calculate P of X, which we called it as marginal likelihood. And of course, we have to calculate X to walk. We called this as likelihood. And finally, I will be getting this value, which is called as posterior probability. So let's calculate all 1, 2, 3 in order to find out the value of 4. So first is First is, so as I have already told, my objective will be to compare these two probabilities. So I will be calculating this for drive, I will be calculating this for walk, and then I will be comparing both the values. And finally, जहाँ पे value high होगी, वो मेरी predicted class होगी. So this is the intuition, which is very common. So I am assuming that X is the event, X is the person for which I have to make predictions, which already occurred. So I want to check that X की क्या probability है कि वो walk करके आए, X की क्या probability है कि वो drive करके आए, और इन values को मुझे compare करना है, और इन values को calculate करने के लिए मुझे ये Bayes theorem apply करनी है. So let's first of all calculate the value of P walk X. X के walk करने की क्या probability है. So in order to do this calculation, I need to calculate P of walk. So let's suppose I have total, for this, the formula is this, number of walkers divided by total observation. So let's suppose I have total 30 observation. मेरे पास ये 10 लोग जो हैं ये walk करके आ रहे हैं, 20 लोग जो हैं वो drive करके आ रहे हैं, और total मेरे पास 30 record है. So let's suppose I have this data set in which walkers are 10, drivers are 20, and total I have 30 observations. So probability of walk will be 10 divided by 30. So this explains that point. So I have calculated this. Now the second point is to calculate P of X. So this is most important point, how to calculate this. So अब इसको ध्यान से सुनना मेरी बात कि इसको कैसे calculate करते हैं. And we called it as marginal likelihood. So here we are talking about something called as likelihood. So कितनी probability है कि P of X की. So इसके लिए हम marginal likelihood find out करते हैं. In this, I will consider an area which I suppose that similar to this my unknown instance. Here, this is my unknown instance, and I will be comparing those. I will be checking those instances which are similar to this. So this is my X. So I will be comparing those instances which are similar to this. And for this, I am using an area of likelihood. So that area can be large, that area can be small. So let's suppose I am using this area of likelihood. So इस area of likelihood में कितने number of data points lie कर रहे हैं मुझे उसको देखना है. So this is my unknown point. I will not count my unknown point in this. So all other data point I will count. So you can see that in this, I am checking number of similar observation to my unknown data set divided by total observation. तो total कितनी observation है मेरे पास, और number of similar observation which is similar to my unknown instance. So here this is my unknown instance, and I want to calculate number of similar observation to this unknown instance. And for this, I have chosen some area of likelihood. And let's suppose this is the area of likelihood. तो मुझे देखना है कि इससे मिलते जुलते कितने data point है. Can you tell me what is the count of those data points which are similar to this in this area? So don't count unknown instance. So it will be 4. So here, here it is 4 divided by total number of observations. So I have total observation 30. So 4 by 30 is the value of P of X. So I have value of probability of walk, which simply tell 10 divided by 30. Then in order to calculate Px, it is based on the concept of likelihood. So you have to first of all consider the area in the neighboring area of X under focus, और आप देखेंगे इससे मिलते जुलते कौन है. लाइक के मीन में भी आप नेबर चेक करते थे ना, तो यहाँ पे भी मैं इससे मिलते जुलते चेक कर रहा हूँ इस लाइक्लीहुड एरिया में कि कितने इंस्टांसेस हैं. एंड यू कैन सी दैट देयर आर 4 इंस्टांसेस व्हिच आर सिमिलर टू x out of total observation. So that way I am getting the value of Px, that is 4 by 30.
Excuse me, sir.
Next, I will take your question after discussing my point. So then next important thing is calculation of this third value, that is probability of walk to x. So this is also very interesting probability to calculate. So अब तीसरा काम है, मुझे देखना है probability of walk, but किसमें से देखनी है? x में. And I have already make a area of likelihood for this x. तो x मैंने यहाँ से बनाया था, लेकिन अब मुझे इस x के ऊपर फोकस करना है, उनके ऊपर सिर्फ जो वॉक करके आ रहे हैं. So I will be focused on x, but I will be only focused on those person who already walking. So I want to check what is the probability that X belong to a person who walked to that particular office. So my only focus will be कि ये first जो है वो walking होने चाहिए, बाकी drivers picture से निकल जाएंगे. तो आप picture में से सिर्फ जो walkers हैं उन्हीं को consider करेंगे, but your area of focus will be again X. So first of all, I will be considering my total number of similar observation among those who walk. So this is a very important formula. Here I am only considering similar observation among those who walk. तो इस area में से जो walk कर रहे हैं सिर्फ उन्हीं को consider कर रहा हूँ. तो total हमने देखा था 4 थे, जिसमें से एक drive करके आ रहा था. लेकिन मैंने बोला कि पहली कंडीशन है कि वो वॉक करके आने चाहिए, तो ये ड्राइवर तो बीच में निकल गया, सिर्फ बचे मेरे पास वॉक करने वाले 3. सो नंबर ऑफ सिमिलर ऑब्जर्वेशन अमंग दोज हु वॉक. सो कितने सिमिलर हैं? 3 डिवाइडेड बाय टोटल नंबर ऑफ वॉकर्स. सो आई हैव हाउ मेनी वॉकर्स? 10. सो दिस विल बी 3/10. सो दैट गिव मी probability of X to walks. So here your first of all focus will be on walkers. So you have I have removed all the drivers from the data set. Then again I draw my X, but now in this case in X I will have only 3 data points divided by total walkers, that is 3/10. So now I have all the values. First of all I calculate P walk, which is very simple. Total number of walkers divided by total, that is 4/30. Sorry, probability of walker, that is 10/30. Then I have to consider area of likelihood. So in this I have to first of all consider my area of likelihood, that let's suppose this is the area, and then in this area I will check total number of data points which are similar to X divided by total observation. So that will be 4/30. Then in next case I have to check walkers, but focused will be on again X. So I have to consider only walkers. So I will remove all the drivers. There are only walkers. Then I have to consider walkers which are similar to similar observation, those who walk divided by total number of walkers. So that number will be 3/10. So now I have all the numbers. I will just put all these numbers into the equation and I will be getting 0.75 as the value. So here I got the probability for कि X walk करके आ रहा है, तो इसकी कितनी probability है? What will be the next step?
We will find out the drivers.
Drives by
drivers.
Yes. So then we will find out for the drivers, and this is intuitive कि जो total probability है, it is always 1. अगर वो walk करके आ रहा है तो उसकी probability 0.75 है, तो driver की कितनी होगी?
0.25.
0.25. तो यहाँ पे आपको कैलकुलेशन करने की जरूरत नहीं है एक्चुअली, एंड यू कैन सिंपली चूज दिस एज अ विनर, और यू कैन विल मेक ए प्रेडिक्शन दैट के पर्सन जो है ये वॉक करके आएगा. बट स्टिल फॉर बेटर अंडरस्टैंडिंग वी विल बी डूइंग दिस कैलकुलेशन अगेन, एंड देन आई विल टेक योर क्वेश्चन आफ्टर दिस. सो लेट्स डू वन मोर स्टेप कि अब हमने ये तो कैलकुलेट कर लिया. Okay, I don't have this in this. Okay, okay, I'm open to take questions. You can ask me any question.
सर वो स्लाइड खोलना है एक बार.
Yeah, please. So I have to open the slide.
सर इससे पहले वाली.
Yeah,
हाँ,
yeah,
yes,
please.
सर इसमें हमने वो प्रोबेबिलिटी निकाली थी ना 4/30, वो एक बार फिर से बताओ सर कैसे निकाली.
ये 4/30.
यस सर.
So उसके लिए हमें क्या करना है? ओके, P of X के बारे में कंफ्यूजन आपको. तो P of X में क्या है कि फर्स्ट ऑफ ऑल वी हैव टू फाइंड आउट, पहले तो इसका नाम समझना जरूरी है. P of X is called as marginal likelihood. So it is a likelihood that the person it is likelihood. So when we talk about a likelihood, it means that we have to consider some neighboring area. We have to consider the data points which look similar to this unknown instance X. So we will be considering some area where we will be looking at all the data points which are similar to X. So this is my X. So I will be taking that particular area of influence. So here I am taking this particular area. And if I'm taking this particular area, you can see that there are 4 data points which are similar to X. ये मेरा unknown है. तो ये जो इससे मिलते जुलते हैं इस एरिया में जो फॉल कर रहे हैं वो 4 हैं. तो जो मिलते जुलते हैं वो 4 हैं डिवाइडेड बाय टोटल. टोटल कितने हैं? 3. तो ये 4/30 हो गया. अब आप नेचुरली क्वेश्चन पूछ सकते हो मुझसे कि सर ये इतना क्यों लिया हमने, ऐसे क्यों नहीं लिया? तो मेरा क्वेश्चन, इसका आंसर ये है कि अगर आप बड़ा लेते ये एरिया, so of course the value will be large. So let's suppose I have taken this, so it will be 1 2 3 4 5 6 7 और 4 ये थे. एक मिनट, 1 2 3 4 5 6 7, तो ये हो गए 11. अननोन को तो छोड़ देंगे ना, तो ये हो गए 11/30. सो P of X बढ़ जाएगा अगर ये एरिया बड़ा कर दूंगा. P of X नीचे डिवाइड हो रहा था, ये वैल्यू नीचे डिवाइड हो रही है. जैसे आप ये नंबर बढ़ाओगे, जैसे आप ये एरिया बढ़ाओगे, इससे ऊपर वाली भी कोई वैल्यू बढ़ेगी? कैन यू टेल मी? इससे जो ये वैल्यू थी,
एरिया बढ़ाएंगे
ये तो फ्रॉम वॉक को तो कोई फर्क नहीं पड़ेगा. अब अगर एरिया बढ़ गया तो सॉरी, यहाँ पे वॉक है, वॉक टू X. तो अब जब आप ये वाली वैल्यू कैलकुलेट करोगे कि X वॉक, तो ये वैल्यू भी क्या हो जाएगी? पहले से बढ़ जाएगी या कम हो जाएगी? कैन यू टेल मी? अब अगर आपका ये एरिया बढ़ जाएगा तो अब आप इस एरिया में से किसको कंसिडर करोगे? सिर्फ वॉकर कंसिडर करोगे. तो वॉकर्स अब कितने हो जाएंगे? ये अब हो जाएंगे 1 2 3 4 5 6 7 8. तो ये वैल्यू हो जाएगी 8 डिवाइडेड बाय 10. तो ये भी नंबर बढ़ जाएगा. तो पॉइंट इज दिस कि ऊपर नंबर एक बढ़ेगा तो नीचे जो नंबर बढ़ रहा है वो ऊपर भी बढ़ रहा है. तो ओवरऑल आपका जो वैल्यू है वो बैलेंस हो जाएगी. सो एरिया ऑफ, अगर एरिया बढ़ाओगे तो नीचे भी कम वैल्यू मिलेगी, ऊपर भी कम मिलेगी. और अगर बढ़ा रहे हो तो ऊपर भी ज्यादा हो रही है तो नीचे भी ज्यादा हो रही है. तो अल्टीमेटली दिस मॉडल ट्यून एंड विल प्रोवाइड यू ए वैल्यू. सो इसलिए अगर आप बोलोगे कि अगर ये मैं एरिया ऑफ इन्फ्लुएंस बढ़ा रहा हूं तो इट विल नॉट चेंज माय ओवरऑल रिजल्ट, बिकॉज उससे नीचे भी वैल्यू बढ़ रही है तो ऊपर भी वैल्यू बढ़ रही है, और उसका जो इन्फ्लुएंस है इंक्रीज का वो आपस में कैंसिल हो जाएगा, क्योंकि एक मल्टीप्लाई हो रहा है तो एक डिवाइड हो रहा है. तो अल्टीमेटली दिस विल बी कैंसल्ड आउट. सो दिस इज माय पॉइंट, माय आंसर इन दिस सिचुएशन. यू गॉट माय पॉइंट कि अगर आप एरिया बड़ा करोगे तो आपकी नीचे वाली वैल्यू बढ़ जाएगी, क्योंकि अभी 4 था, आपने बड़ा कर दिया सर्कल, तो अब आप बोलोगे कि भाई इस सर्कल में मेरे पास अब 11 आ रहे हैं, तो ये 11/30 हो जाएगा. सो नीचे वैल्यू बढ़ गई है तो वैल्यू ओवरऑल फार्मूला जब कैलकुलेट होगा तो छोटी हो जाएगी, लेकिन छोटी नहीं होगी. क्यों? क्योंकि ऊपर एक वैल्यू बढ़ भी रही है. तो ये
12/30 नहीं आना चाहिए से, क्योंकि 8 हमारे पास रेड स्पॉट्स है और 4 हमारे पास ग्रीन है, 1 अननोन हो गया. तो
चलो वो 12 कर लो, दैट इज नॉट द पॉइंट. सो 12/30 हो गया. सो अब नीचे जो वैल्यू बढ़ रही है वो ऊपर, नीचे जो वैल्यू बढ़ने के कारण ओवरऑल फॉर्मूला की जो वैल्यू है वो कम होनी थी, बट कम नहीं होगी. दिस इज माय पॉइंट, क्योंकि आपकी जो ऊपर वाली वैल्यू है वो भी सेम रेशो से एक तरह से बढ़ रही है, बिकॉज अर्लियर यू आर जस्ट हैविंग 3/10, क्योंकि इस एरिया में 3 वॉकर आ रहे थे, लेकिन अब आपके जो वॉकर हैं वो भी 3 के अलावा 4 5 6 7 8 आ रहे हैं, तो अभी 8/10 हो जाएगी. तो ओवरऑल जो इन्फ्लुएंस है वो कैंसिल हो जाएगा और अल्टीमेटली यू विल बी गेटिंग द सेम वैल्यू. So let's do calculations again for this division. तो उससे मुझे लगता है कि concept और clear होगा.
Can I ask a question, sir?
Yes, please.
Sir, in the real-time cases when we have real data, so is there any criteria on which we can somehow narrow down which classifier to use, or it's purely hit and trial basis?
You can narrow down on the basis of linear and non-linear only.
Okay.
So that can be the guiding line. आप लीनियर लेना चाहते हैं, नॉन लीनियर लेना चाहते हैं, so
Okay.
that can be useful.
Okay. Thank you, sir.
So can you calculate the value of this drivers की जो है वो calculate करेंगे? मेरे
It
पास
came 1/4.
yeah. So we have calculate this value for walks. So can you calculate this for the same? So
Yes.
take your time and calculate the values, and let's see what is the value. So I'm waiting for your response. Just take 1 minute for the same data set. Now consider this. So let me copy this for you, and I am putting everything here. So मैं यहाँ पे ये फॉर्मूला आपके लिए यहाँ रख रहा हूँ, और अब आपको ये कैलकुलेशन करनी है. So put all the values. So let's first find out P of drives. P of drive कितना आएगा?
20/30, sir.
20/30. Very good. And what about P of X?
4/30.
4/30, sir.
So P of X same रहेगा. This is important to note. तो आप चाहे वॉकर के लिए करें या ड्राइव्स के लिए करें, P of X सेम रहेगा. ये 20/30 हो गया, ये 4/30 हो गया, और इसकी वैल्यू क्या आएगी?
1/20, sir.
1/20.
1/20. Very good. So if you put all these values, what will be you?
1/4, sir. 1/4, 25%.
So 0.25 you have obtained. Very good. So this is what I want that you should do on your own. Okay, so you have calculated it, and so again you can share your results on the chat box so that one can cross check their results. Yeah, you are doing this. Okay, so now let's move next. I have one little bit more concept which I want to explain with you. So now there are two additional very important questions that why this is called as naive algorithm. So of course, base क्यों कहते हैं? क्योंकि ये base theorem के ऊपर है. Why we called it naives? So can anybody tell me why it is naive?
Sir, because it is on the name of scientist.
Because it is on the name of?
Yes.
ना उसके साइंटिस्ट पे तो बेस था ना, उसका नाम बेस था, उससे बेस आ गया. नईव क्यों? नईव उसका नाम नहीं था.
We are making assumptions.
What assumption we are making? So naive. Yeah. What is independent assumption?
Features of measurements.
Yeah. So very good point. So I like your answer. So why naive? Because here we are assuming that our input features are independent. मतलब उनका आपस में कोई रिलेशनशिप नहीं है. इनपुट फीचर्स मैंने लिए थे, एक तरफ एज और एक तरफ सैलरी. तो मैं ये मान के चल रहा हूं कि एज और सैलरी आपस में इंडिपेंडेंट है. तो जो naive algorithm, naive based algorithm है, it assume that all input attributes, इससे ज्यादा भी हो सकते हैं आपके डेटा सेट में. So all input attributes are independent with each other. But if there is some dependence between these input attributes, then the accuracy of naive based model will be not that great. So this is the point. So naive based algorithm ये assume करके चलता है या वहां बेस्ट काम करता है जहां पे आपके जो फीचर्स हैं वो एक दूसरे से इंडिपेंडेंट होते हैं, because it assume that there is all these are independent attributes which are dependent on one class attribute. So it assume that input attributes are independent. But can you tell me age and salary वो input attribute है, इसकी बेसिस पे मैं प्रिडिक्ट कर रहा था कि वो परचेज करेगा या नहीं करेगा. तो एज और सैलरी क्या आपको लगता है ये इंडिपेंडेंट है या डिपेंडेंट है?
डिपेंडेंट.
So normally age and salary are little bit dependent, कि जैसे जैसे बंदा ग्रो करता है उसका एक्सपीरियंस बढ़ता है और उसकी सैलरी बढ़ जाती है. तो जो यंग एज के हैं उनकी सैलरी कम होगी, जो हायर एज में है उनकी सैलरी ज्यादा होगी. There is a trend, but so there is a little bit dependence between age and salary, but that dependence is completely ignored by Bayes algorithm because it assumes that these are independent with each other. But the beauty of Bayes algorithm is that still having this naiveness in nature, still that algorithm produce most of the results very accurate. And this algorithm gives a very good result in most of the situation, and that's why it is used in most of the classifiers. But it is important to understand that we got the term naive because it assumes that our independent attributes are independent, and this is very naive assumption because most of the time it does not happen that way because data input attributes are dependent in a way. Second discussion is on P of X. मेरा क्वेश्चन है, क्या हमें P of X हमेशा हर बार कैलकुलेट करना चाहिए या इसको छोड़ सकते हैं? सो अल्टीमेट देखना, अब अल्टीमेट देखना करना क्या था, हमें P of वॉक की वैल्यू फाइंड आउट करनी थी, फिर अगली बार मुझे P of ड्राइवर की वैल्यू फाइंड आउट करनी थी और उसको आपस में कंपेयर करना था. यही लॉजिक हमने बनाया था ना कि फर्स्ट कैलकुलेट P of walk, then calculate P of drive. So this is P of walk, this is P of drive, and then compare it. So जब आप कंपेयर कर रहे हैं तो दोनों तरफ में जो नीचे मैं डिवाइड कर रहा हूँ वो P of X कर रहा हूँ. So actually it is not contributing in the final output. So for simplicity you can just ignore P of X and only you can calculate P ऊपर वाली जो टर्म है उसी को कैलकुलेट करें और उसी से आपकी जो वैल्यूज है वो मिल जाएगी. एंड नॉर्मली वी अज्यूम दैट P of X is 1 और इसको हम कैलकुलेट नहीं करते एंड वी अज्यूम दैट कि दिस हैज ऑलरेडी बीन अकर्ड एंड P of X is 1. So this is just will not influence your output because anyway you are comparing it and it got cancelled in both the situations. So this is another important point. एंड थर्ड इंपॉर्टेंट डिस्कशन जो इसमें यहाँ पे हम कर सकते हैं कि अगर आपकी दो क्लासेस हैं तो आपको सिर्फ एक की प्रोबेबिलिटी कैलकुलेट करनी है, दूसरे की करने की जरूरत नहीं है. बिकॉज आई हैव, क्योंकि आपने पहले बार देखा कि 0.75 थी तो दूसरे के लिए सारी कैलकुलेशन नहीं करने की जरूरत क्योंकि 1.75 आपको पता चल ही गया था कि 0.25 आने वाली है. मेरा क्वेश्चन है कि अगर 3 क्लासेस हैं देन आपको कितनी प्रोबेबिलिटी कैलकुलेट करनी चाहिए, कितनी के लिए कैलकुलेट करना चाहिए, कितनी क्लासेस के लिए कैलकुलेट करना चाहिए?
दो के लिए.
सो अगर आपके पास n क्लासेस हैं तो आपको मिनिमम n-1 के लिए कैलकुलेट करना चाहिए बिकॉज यू कैन कैलकुलेट द वैल्यू ऑफ थर्ड ऑटोमेटिकली इन केस ऑफ 3 क्लासिफायर. इफ देयर आर 4 तो आपको 3 के लिए कैलकुलेट करना है. सो दिस इज द पॉइंट. इफ यू हैव मोर देन 2 क्लासेस then you have to compare the value of n-1 classes so that you can get your values. So this is naive Bayes. So let's quickly implement it. So let's look for the code. तो इससे हमारे जितने भी क्लासिफायर थे वो मैंने पूरे कर लिए हैं and I will be closing this session after this. और अगली बार हम as we have discussed कि जो text classification है that is also very important because most of the time people are working on a data which is text in nature. For example, अगर आप sentiment analysis पे काम कर रहे हैं so you will be not having a data set like this, you will be having data set in term of text. So that is considered as text classification. मान लो आपके पास एक document है and you want to check the class of that document whether it belongs to politics or sports or something like that. Again, you require a text classifier. Similarly, if you have some article and you want to check whether it is real or fake, again it is a case of text classification. So there are very huge examples where we can apply text classification. So we will be discussing text classification from the next week, and this is the simple code to call naive Bayes classifier. So here you can see that in naive Bayes sub-library I have a Gaussian NB which I am implementing as a class and I am just creating its object. इसको कुछ भी पास नहीं किया हमने. So Gaussian NB एक class है where we have a method fit and predict. which implement naive Bayes in Python. So simple 2-line code, everything will be same. So I have this. Now let's check confusion matrix for naive Bayes. So it is 7 and 3, 10. It's not that accurate. So let's see its, you can say, visualizer. So this is the visualization of, this is the visualization for support vector machine, जो हमने पिछली बार निकाला था. And this is the visualization of naive Bayes. So naive Bayes भी support vector machine की तरह है. But support vector machine, you can see that little bit more precise. मतलब ये इसकी जो shape थी वो little bit more precise. That is little bit more accurate. And this is here I am little bit more generalized. But still it is a non-linear. Important point to note that कि जो naive Bayes है ये non-linear है और ये support vector machine जितना accurate नहीं है क्योंकि उसकी जो non-linearity थी that is little bit more specific as compared to this. So yeah, so this is naive Bayes. An important point to take is that this is a non-linear classifier. With this, I will complete my session. So yeah, so now what we are doing, we have a lot of students from Thapar. So what I am thinking कि हमारी अब अगली class होगी 22nd को. So from 22nd May, we will be discussing text classifier जो मैंने आपको बोला है. And I will also be trying to touch artificial neural network in our next session. So then there will be two topics which will be pending. One is artificial neural network and another is clustering. So I will be taking that particular topic, clustering and artificial neural network implementation, after taking a break for 2 weeks maybe. So this will be our plan. So let's have a quick quiz.
Sir, I have a question.
Yeah, please.
What's the difference between k-mean and KNN algorithm?
Yeah, k-mean is completely different. K-mean is a clustering approach. It is not a classification. So k-mean जो है ये clustering के लिए है. जब data आपका labeled नहीं होगा, आपको grouping करनी है, clusters बनाने हैं, then we will be using k-mean algorithm. So it is completely different concept, and I will be covering this during clustering. Here we are discussing classification. We are predicting whether it is yes or no or what will be the class. But in case of unsupervised learning, where data is not labeled, we just have to make clusters. And in order to create those cluster or group, we use k-mean, and it is based on the concept of finding the mean of group. So we will be discussing that in more detail in one of the separate session under unsupervised learning. So let's start this quiz quickly. Join it. We have 6 questions. So this is the code. Let me share this over YouTube. So I have shared a link at YouTube as well as on this. So please join. So how many we have? So let us start. We have approximate 86, 87. Okay, let's start. How many are on YouTube? So we have just seen that KNN and A-base are not linear. We only have logistic regression, which is linear. Last question. Let us see the scores. Good. So Kanuj, congratulations. Please unmute and introduce yourself to all of us. Kanuj. Yes, Kanuj. Abhinav, Prabnu, Preet Kamal, Astha, all of you, you are a top 10, and out of 116, top 10 is a good position. So please introduce yourself to all of us. Anyone can unmute whose name is there on the screen.
Hello, sir. Myself, Prabhdur Singh from COE, Thapar University, Patiala, second year.
Second year. Okay, good. God bless you.
Sir, I am Preet Kamal Kaur and I am a research student in Punjab University, Patiala.
So you are working in which department?
Sir, computer science and engineering.
On which topic you are working?
Sir, my topic is basically image processing plus machine learning.
So you are doing your PhD?
Yes, sir, I am doing PhD. I have just started, so I am working on my topic
Who is
selection.
your supervisor?
Sir, Dr. Nirvan Nehru,
Okay.
ma'am.
Okay, good. God bless you.
Thank you, sir.
Yes, next.
Hello, sir. I am Abhinav. Basically, I passed out from Thapar University, and I am an alumni of Thapar only.
Great.
And
Good.
currently, I have experience of 2 years in software industry.
So you are
So
passed
right,
out from computer or some other branch?
I passed out from electronics.
Okay, electronics. और अभी किस कंपनी में हो?
अभी सर मैं क्लियर वाटर एनालिटिक्स में हूँ. So,
And in which
here I
city?
can you repeat, sir?
कहाँ पे हो, किस शहर में हो?
It's in Noida.
Good. अच्छा लगा तुझसे बात करके. And you are from which city? Otherwise, you belong to which city?
Sir, Delhi.
Okay, good. God bless you.
Thank you.
Yes, next. Yes.
Good evening, sir.
Good evening.
Sir, I am Devansh Marwaha and I am a student of BTech third year from Guru Nanak Dev University.
Guru Nanak Dev University, Amritsar campus?
No, sir, regional campus, Jalandhar.
Jalandhar. Okay, you are from Jalandhar?
Yes, sir.
Okay, good. God bless you.
Thank you, sir.
Yes, next.
Good evening, sir. I'm Rajveer of second year of Thapar University. I'm from ENC branch.
ENC. Chalo, badhiya, good. Thank you. Yes, next. Yes, Riya, Mayank, Astha.
Good afternoon, sir.
Good afternoon.
Yes, sir. My name is Kanuj Bura and I am a second year student at Thapar CSC branch.
That's good. Thank you.
Thanks, sir.
Next, anyone, please. So good. It's interesting to contact with you on Zoom. Wonderful platform. अलग-अलग बैठ के भी हम बहुत कुछ कर लेते हैं इसके साथ. So ठीक है फिर I have to share attendance link. So we will be meeting next week at the same time, and we will be covering text classification, and if time permit, we will also start our discussion on artificial neural network, and then we will break. आपके कब खत्म हो रहे हैं बच्चों MST?
Sir, 6 June.
11th June.
6 June, sir.
चलो, we will decide a date accordingly. उसके बाद देख लेंगे जो भी डेट होगा जब आप सभी फ्री होंगे. So this is session number 8.
Yes, sir.
So please don't share this link with the other people. Only those who are attending either on YouTube or this. So please fill this form. Yes. So please don't fill proxy attendance. So has a way, otherwise it will affect others also. Good. If you have any suggestion, any point to make, you can tell that. So you can suggest me something that how we can make it a little bit more useful next time when we will be conducting this course in future. So how we can make it a little bit more engaging so that everyone complete this course, because a lot of students drop in between. So any suggestion from your side for?
Can we implement any basic one research paper so that the research scholars can get some idea who are starting their research that how to implement the research papers?
Yeah, we will. I hope that the next session will be a little bit more useful on that. So yeah, we can do that also. Yes. But my question is how we can make it a little bit more engaging so that there are a lot of students who drop in between. So how we can reduce that number? Any idea, any suggestion on this point? So we have approximate 120 students. So I'm going to stop now accepting the responses. Hurry up. Okay, thank you. Thanks for joining. God bless you.
Sir?
Yes.
Sir, actually I heard about a Kaggle from some of the colleagues in my office. तो Kaggle.
Kaggle में data sets होते हैं हमारे पास, from where you can take a problem statement and you can work on that. So this is a public platform where people share their data set and sometime code and data sheets. So you can use that.
तो अगर हमें प्रैक्टिस करनी हो ML मॉडल्स के लिए जो आपने पढ़ाया तो हम Kaggle पे यूज कर सकते हैं वो सारा कुछ?
या ऑफ कोर्स Kaggle पे आपको डेटा सेट मिलेंगे और उन डेटा सेट्स के ऊपर फिर आप कोई क्लासिफिकेशन, रिग्रेशन ये वो सब कर सकते हैं. देयर आर लॉट ऑफ प्रॉब्लम स्टेटमेंट्स ऑन Kaggle. There are also some competitions there, so you can join any and you can participate in that. Yeah, this is a good resource. Even GitHub is also there, so similar kind you will find some resources over GitHub, so you can explore all these resources.
Thank you, sir.
And even I suggest you all people that if you can keep on sharing some good projects or some data sets on our WhatsApp group, it will be good. And that way you can help other people to work on these problem statements. So don't only rely on me. It will be good if you all contribute in this course. And I will share this information on WhatsApp where I will request all of you to contribute in this direction, where you can share some problem statements and data sets where all of you can work.
Sir.
Yeah.
सर एक डेटा सेट था सर, मॉल स्ट्रक्चर, मॉल कस्टमर्स करके सर मैंने टेलीग्राम के ग्रुप में भी डाला है सर. जब उसके ऊपर KNN अप्लाई कर रहे हैं सब कंफ्यूजन मैट्रिक्स निकाल रहे हैं, वो बड़ी अजीब सी कंफ्यूजन मैट्रिक्स आ रही है, उसके अंदर बहुत सारी लिस्ट आ रही है और उन लिस्ट में 0 और 1 है बस.
So बाकी भी आपने अप्लाई किए थे उसके ऊपर?
नहीं सर, मैं KNN ही अप्लाई करके देख रहा था अभी.
एक बार बाकी भी अप्लाई करो and then you will be in a better position to understand why you are getting this, and you have to look into that how many records you have and how many of them are actually classified accurately. So you need to be a little bit more in an analytic mode to understand this. Of course, we can have image data set in our ML model, and for this we have convolutional neural network CNN model. And if time permits, we can also take one session on CNN maybe after your end semester exams in next month. We can plan this also. If you are interested, we can have a session on image data set.
Thank you, sir.
Okay, thank you. Bye.